Good morning. Today we're going to take a look at solving exponential equations. This will be the last topic that we look at this school year. So we've looked at some exponential equations already. An exponential equation would be something like 2 to the x power equals, we'll say 16. So obviously you have an equation, which makes an equation, and the variable we're trying to solve for, x, is in the exponent. That's what makes an exponential equation. So we've looked at things like this already. We know that 16 is the same thing as 2 to the 4th power. If the bases are the same, then the exponents have to be the same. We have x equals 4. That works well for things like 2 to the x power equals 16. But if we had something like 2 to the x power equals 25, then we can't do the same thing as we did with the first equation, because with the first equation, 2 and 16 are both powers of 2. But 25 is not 2 raised to any particular power, not a nice neat number. We know that 2 to the 4th power is 16, and 2 to the 5th power is 32. So that means our x has to be somewhere between 4 and 5, maybe 4.6, something like that. Same thing if we had, let's say 3 to the x power equals, let's go with 20. So we know 3 to the 2nd power is 9, and 3 to the 3rd power is 27. So this exponent has to be somewhere between 2 and 3, maybe 2.7. I'm just guessing there, but I know it has to be between 2 and 3. And same thing if we had, let's say, 5 to the x power equals 50. So we know 5 to the 2nd is 25, and 5 to the 3rd is 125. So in this case, our x has to be somewhere between 2 and 3, maybe 2.3, something like that. So if both sides have bases that are both powers of the same number, in this case 2, we can rewrite the one side as 2, in this case, to a power. But for all of these examples, here 25 is not a power of 2, 50 is not a power of 5, and 20 is not a power of 3. To solve those equations, we do the following. Let's go through and look at each of those. So we'll call this example 1, example 2, and example 3. So if we have 2 to the x power equals 25, we have a couple different options. One thing we can do is rewrite this in logarithmic form. Remember, logarithms are exponents, so we can say log base 2 of 25 is equal to x. And for these problems, we're going to end up using the calculator. The problem with something like this, log base 2 of 25, is when we go to the calculator, we don't have a log base 2 button. We have a log button and an ln button. So remember, a log button is log base 10. The ln button we'll get to, you'll look at that in pre-calc, but that's something where you have log base e. And you're thinking e is not a number, but just like pi is 3.1415, e is about 2.718. We could spend a week talking about e and where it comes from and stuff like that, but that's going to be something we'll save for later. But we're going to use this log button where we have log base 10. So the idea with these, since we need a log base 10 button, we can't use log base 2. What we can do is log both sides of the equation. Again, basic algebra, whatever you do to one side, you have to do the other side. Then we do log. Remember, we're doing log base 10. We're just not writing the 10. And then from here, we use the properties of exponents. Remember, exponents can become, properties of log, where the exponent can become a coefficient. So we're going to make that x a coefficient. Remember, log 25 is just a number. That's whatever 10 to the power needs to be to get 25. So this whole thing is a number, and log of 2 is also one number. So just like if you had 2x equals 5, you would divide both sides by 2. We're going to do the same thing with log 2, which is just a number. Log 2 divided by log 2 is 1 times x is x. And this is where the calculator comes into play. We're simply going to type this into the calculator because log is log based. So in the calculator, we can type in, let me see what it was now, log 25 over log 2. So we can do the log 25 divided by the log of 2. That gives us 4.64. We'll round and say 644. Which if we look at our guess up here, we know it had to be 4 point something. And 4.6 is actually a pretty good guess. So you might see in a textbook, this is what's called calculator ready form. Because you've done all the algebra and you're ready just to put in the calculator. And then this would be not an exact answer because like pi, it's a decimal that goes on forever and ever. This would be our decimal approximation. I look at the other two examples real quick, and that'll be it then for today. So 3 to x equals 20. Again, we could rewrite this as log base 3 of 20 equals x, but our calculator doesn't have a log base 3 button, so that's not going to help us. So we're going to log base 10 since our calculator has that button, or just log both sides. Exponents can become coefficients with the logs. And then log 3 is a number, so we're going to divide both sides by the log of 3. And then we have our calculator ready form, and we can just go to the calculator and put that in. So log 20. So we have log of 20 divided by the log of 2.727. And if we look at our guess earlier, we said 2.7 something was a good guess, and that actually ended up being a very good guess. I want to show you real quickly one thing you can do on a calculator to make these a little bit easier to enter, because with the parentheses it can be a little bit confusing. If you go to go to alpha y equals, it's going to give you this menu, and option 1 is fraction form numerator over denominator. So we choose option 1, it actually gives us a numerator and denominator, and we can just type in log 20 over log 3, and we don't have to worry about the division symbol and worrying about doing a log of 20 divided by 3. We can just do log 20 over log 3. So it's just another way to enter in the calculator. All right, we'll do that last example then. Let's see, 5 to x equals 50. Again, we could go to logarithmic form, log base 5 of 50 equals x. And hopefully what you've noticed with the first two, this example, this as we written as x, same as this. And this that we rewrote as x is the same as this. There's actually something called the change of base formula, which says if you have log base b of a, any base, you can rewrite that as log any base you want. We're going to call it, we'll call it n of a over log base n of b. We use log base 10 because that's what our calculator has. So we could rewrite this as log base 10 of 20 over log base 10 of 3. And that's the same thing that we got down here. This is the algebra for why it works. This is just a shortcut, something that's called the change of base formula. And with a change of base formula, you can use any log you want. So we could rewrite this as log base 17 of 50 over log base 17 of 5. Just log base 17 doesn't make a lot of sense because we don't have a log base 17 button on a calculator. But we do have a log base 10 button on the calculator, so we can do log base 10, I'm not going to write the 10, of 50 over log base 10 of 5. And all that does is skip this algebra here, which we will need to do when we get into some slightly more involved examples, but for now we can not worry about that. So log 50 over log 5. We have the log of 50 divided by the log of 5. 2.431. And again, from our guess up here, number 3, we guessed 2.3. We ended up with 2.431. So that's it for today. Just a quick thing on solving logarithmic equations.